about today, you already know. We have our original trig functions, sine of x, cosine x, tangent x, and so on. And then we have the reciprocal trig functions. Okay. So when you have a sine of x, it's the same thing as saying, move these over a little bit here. What's the reciprocal of sine? 1 over sine, right? Which would equal cosecant, right? So, excuse me. So if we take the reciprocal of sine, how would we write? If I take the reciprocal of sine, it equals cosecant. We know that. I'm going to do something that's going to be a little bit different for this section, just because there's so much of it. I'm not going to write down x. I'm just going to write 1 over sine is cosecant. Okay? It doesn't mean that it's not there. It just means that it's just gonna. I'm trying to make it look a little bit cleaner with all the x's and the thetas and all that kind of stuff. Because if you keep writing all that out, it gets really messy. Okay, it's just one thing that I've learned over the course of years. That sometimes it's cleaner. Same idea with if I do it this way. 1 over cosine is equal to what? Secant. Okay. And then 1 over tangent is cotangent. Good. Now, I can do the same thing. Remember when you have fractions, you can exchange things on the diagonal and it doesn't change anything? Same deal goes for it. I can say then that 1 over cosecant is sine. 1 over secant, because all I'm doing is reciprocal, just by flipping it, and I'm going to be able to go back to cosine. And then, last but not least, 1 over cotangent is tangent. There is one other thing that we can rewrite with tangents and cotangents. Tangent is what over what? Do you guys remember? Opposite over adjacent. We also can say it's also sine over cosine. So we also know that tangent is sine over cosine, which means cotangent is very good. So we get into little stuff like this. And what we're going to be able, bless you, what we're going to be able to do is we're going to be able to rewrite things in simpler forms. All this, if you look at this, anywhere I see a sine, I can write it as 1 over cosecant. Everywhere I see a cosecant, I can write it as 1 over sine. Everywhere I see a tangent, I can write it as sine over cosine. There's a boatload of what we wind up doing in what's called direct substitution. Okay. Excuse me. We also have these other Pythagorean identities, okay? And there's going to be 3 of those. And one of them I kind of showed you a little bit yesterday. Let's see here. The 3 Pythagorean identities are going to be sine squared plus cosine squared is 1. And then we have 1 plus tangent squared is secant squared, and 1 plus let me move this over just a bit. 1 plus cotangent squared is cosecant squared. What you can do with those 3 is you can manipulate to get sine squared by itself. You can manipulate to get cosine by itself. I can manipulate to get tangent by itself. I'm using tangent squared. I can manipulate to get cotangent squared. There's a lot of little things you can do just by moving things around in the equations. These Pythagorean identities, I showed you guys that one quick example the other day with an equation where you had sine squared and a singular cosine. Bless you. We use these a lot within equations. What we're going to work on between, just to kind of little bitty start of it, just a little today. I'm going to mainly focus on just the standard stuff, just quick, how do you rewrite and things like that. But remember, what you can do is, remember the thing called solve a literal equation? Remember what that means? You do when you see this. What's that stand for? Distance equals rate times time. If I wanted to get rate by itself, what would I do? I divide by time. So you're basically working with what's called a literal equation. You're isolating a variable. So if I want to isolate sine squared, I could say that sine squared is 1 minus cosine squared. Also, I could say that cosine squared is 1 minus sine squared. Just by moving things over left and right. Same deal with tangent squared. I can get tangent squared by itself by saying and then cotangent. If tangent is sine over cosine, what do you think tangent squared is? Louder, Haley, you're right. If cotangent squared, or excuse me, if cotangent is cosine over sine, cotangent squared would be cosine squared over sine squared. If secant squared would equal 1 over cosine squared, all those same reciprocal properties and the ideas of all that all holds true with higher degrees. It all works because it's the whole thing. Because we can turn it into a fraction and raise it to the power, and it works. Right? So what you're going to be able to do is something like this, and I might have to turn off the light so you can see it. I know it's not funny, but it used to be really, really funny. Okay, all right. I know it's distasteful nowadays a bit, but here's why this happens. When you are dividing fractions, or when you have a fraction, it's something divided by something. Do you guys agree? Which means I could rewrite this as sine times 1 over tangent just by pulling it apart. 3/2 is the same thing as 3 times 1/2. 19 pi over 3 is the same thing as 19 pi times 1/3. Okay? Just by pulling apart fractions. Now, 1 over tangent, same thing as what reciprocal property? Cotangent. So what you're able to do here is rewrite this as, well, that's sine times cotangent. And what is cotangent in terms of sines and cosines? Bless you. Bless you. Cosine over sine. So you get sine times cosine over sine. And what drops? All you're doing is rewriting. Direct substitution and rewrite. So that's where you get the cosine or sorry. Or how about this one? Good morning, sir. Thank you. What if I do this one? Let me write this real quick. So what would sine gerene over cosine gerene equal? Tangerine. I'm sorry. It's better than the Cosby joke. Okay. let's simplify this. Now, by all means, write it out as cotangent times secant. And I will give you a giant hint. When you have anything that is a reciprocal property, or if you ever have a cotangent or a tangent, always try to rewrite in terms of sines and cosines. Always try to rewrite it in terms of sines and cosines, because when you rewrite things in terms of sines and cosines, you get fractions, and then when you have fractions, things can simplify. Well, there's no equal, so there's no exchange or change. Okay. So if I'm looking at cotangent secant, cotangent is what over what? Cosine over sine. Good. So this becomes cosine over sine. Secant is 1 over cosine. Good. Since I'm multiplying, what drops? Cosine. Is the sine wearing a flotation device? No. What is 1 over sine? I hope you're not drowning in a car in driver's ed. We don't have a pool. Why are you driving the river? How do you pop the window? Have you never watched Mythbusters? Okay. All right, here we go. Let's try another one. Guys. Now, whenever you see a 1 plus a tangent squared, 1 plus a cotangent squared, a 1 minus something with a square term, always try to go back and look at one of your Pythagorean identities. 1 plus cotangent squared is the same thing as what? Cosecant squared. Very good. So that means that I have sine times cosecant squared. Well, cosecant is the reciprocal property of what? Sine. So cosecant squared is the same thing as 1 over sine squared. What drops? Just one of the sines. Which leaves you 1 over sine, which means your answer is. Does it mean like all of your answers are going to wind up being cosecant because we've done 2 in a row with equal to cosecant? You're right. Yes, every answer is always Peace out, dude. Hey, 80% statistics are made up on half on the spot, and they're half right. Or is it half wrong? Where do you start? Now, there's a couple of ways you can do this. One of them is, and go to the next problem. Because there's a property now, let's say you forgot that, which is at all completely possible. Okay? Secant squared is the reciprocal property of what? Cosine squared. So I could write that as 1 over cosine squared. Tangent squared I can rewrite as a sine since cosine. It's 1 over what? So it's sine squared over cosine squared. Now, do I have a common denominator? Yes. So that means I can put them together, and I get 1 minus sine squared over cosine squared. What's 1 minus what's 1 minus sine squared? Cosine squared. I like the other way too, but let's say you forgot. Okay. What happens, hey guys? What happens with a lot of this, and I'm not going to get to. I don't want to do anything with verify today. All this stuff is that I'm looking at today is I want to figure out ways to simplify. Okay. All I want to do is use a couple identities, a couple of things to go through and simplify out. I already posted a PDF file. Get the right one of these. That's not my classroom. There it is. I posted this PDF file. Yeah, and I want to do a couple of them that we had not gotten into yet, like a couple of tricks. For example, what happens a lot with these things, you'll have trig identity minus a trig identity plus a trig identity, which means you have to generate common denominators. Okay. So I wanted to simplify this. Notice again, you've got a reciprocal property, a sine, and a tangent. Which means I should probably rewrite everything in terms of sines and cosines. That's the easiest way to go at any one of these problems at any time. It makes the most sense, it's the most efficient way of doing it, and it's a lot less brain power. Because we all know that secant is the same thing as 1 over cosine. Tangent is 1 over what? Sine over cosine. So what I do is I immediately write in terms of sines and cosines. Do I have a common denominator? Yeah. What's sine times sine? What's 1 minus sine squared? What's your answer? There's your answer. It's the idea of rewriting in terms of the generics, if you will, sines and cosines. But if you hear me say rewrite in terms of the generics, that's what I mean. Rewrites, always try to go to sines and cosines. It's a lot easier, a lot less brain power. Okay. Wait. Sorry. What's that? This is?
No one's count. There are no numbers there.
You can put a number there. As long as it's the same number the whole way through, it works. Yes, ma'am. To be honest with you, you know all of those already. You know those three. That's really what because then you can rewrite them. Because you already know all the basics. All right. Oh, what was the other one here?